Hey, it's so great to be here today. It's great to see so many faces that I've seen before and so many new faces. I'd love to start, how many people actually run Mesos today? If we could just get a show of hands. That's awesome. This half, not this half. I'm just kidding. You guys all knew each other. No, I'm just kidding. That's great. That's great. I think that's a really good mix. It's nice to see a good mix between people that are not using it and people that are using it. So I've got a really brief talk. I didn't want to take too much of everyone's time today. I just wanted to kind of set the scene, talk a little bit about Mesos, and then get you all ready for what I think is going to be a great day. We've got a great program. So this is MesosCon 2014. And as Dave mentioned, I'm the chair of the project, the VP of the project. So in some ways, this talk is kind of like, from where I sit, or a chair's report, or something like that. What I'm going to spend a little bit of time talking about is why Mesos, and then I'm going to talk in more detail about the current state of the community and a lot of cool stuff that we're actually doing in the project. So when thinking about how I kind of wanted to explain why Mesos, especially why today, and why you're all here, I was reminded of this great quote. Not quote, this great sticker that I used to see when I was younger, when I was an undergrad in grad school. And the sticker read, "My other computer," and does anybody know what the rest of the sticker said? No, it didn't say that one, but that's what I'm going to say. It said, "is a cray." Right? This was the awesome marketing that Cray did back in the days. My other computer is a Cray. But I think a lot of us are here today because we realize that actually our other computer is a data center. We've got our laptops, we've got our phones, and our other computers is really a data center. And when I say data center here, I really just mean any collection of machines, whether it be a collection of physical machines, whether it be a collection of virtual machines, or whether it be a combination of the two. But this idea that actually all these machines that we have somewhere running, we really want to pull together and treat as one big computer. And it really is our other computer. And there's kind of two perspectives that you can take when you kind of ask why you want to treat your data center like a computer. And the first is the ops perspective. It's to a lot of operators, more and more, the data center is just really another form factor. The way that they want to run applications on their laptops, the way that folks want to run applications on your tablets, and the way you want to run applications on your cell phones, is exactly like the way you'd really love to run applications on your data center. And there's no real reason why we couldn't run applications on our data centers in exactly this way. And it was the same with the Cray, right? I mean, this was a supercomputer, but we ran applications on the Cray just like we run applications on single server machines today. And I think that really begs the question, which is, why can't we run apps on our data centers just like we run applications on our mobile phones? On our mobile phones, the view that you get is, oh, here's just a bunch of applications that I have running, and I can toggle between those applications, and they can effectively utilize the resources of my mobile phone. Whereas in the data center, what most folks end up doing is something like this. They statically partition their data center up into a whole bunch of different collections of machines that are specific to a particular app, and then they manually manage the resources that come in and out of those static partitions. Right? So that's kind of from the ops perspective is, why do I want to deal with this? Why can't I just treat my data center like one big computer? And from the dev perspective, developers, many of you possibly out there today, they're all saying, well, the applications that we're writing, they just don't fit on a single computer anymore. They really need data centers, right? Well, it's either because they're big data apps, and they need to run across lots of machines because the amount of data that they're actually trying to compute is really, really large, or they're apps which deal with large numbers of users. So you got lots of data, you got lots of users, and these things are growing every day. These things are continuing to get bigger and bigger every day. And so for these new developers, these applications that they're writing, they need lots of resources. They need lots of CPUs, they need lots of memory, they need lots of disks. They really need data centers to actually run their application, which means at the end of the day, we're all building distributed systems. There's a great ACM article from a couple years ago called "There's no denying it. Everyone's building a distributed system." But unfortunately, even though we're all building distributed systems, everybody keeps reinventing the wheel. Right? Everyone keeps building the same aspects of each distributed system over and over and over again. And really, for a lot of these systems, what we're getting is this. We're getting a lot of square tires and triangle tires. And I think that one of the questions that we often ask ourselves is, how many more buggy failure detectors are people going to build in their distributed systems until eventually we stop building those and we start leveraging common frameworks that we can use to actually build our systems. So to do something like that, what the data center computer really needs is something like an operating system. Right? We've had an operating system on our desktop computers to help us run our applications. The same thing with our servers. And now what we really want is we want something which can combine all these machines together and give us an interface so that we can program against this data center, and then we can run our applications against this data center. And what I think is kind of fun is actually taking the quote from Wikipedia that describes what an operating system is. It says, it's a collection of software that manages the computer hardware resources and provides common services for computer programs. And I think it's, all you really need to do is just insert the word data center in the beginning of that, and you say, all right, a data center operating system is a collection of software that manages the data center computer hardware resources and provides common services to computer programs. But that second part is the thing that I think is especially interesting, that provides common services to computer programs. So if we can provide these common services, then everybody can stop reinventing the wheel, and they can use these things to build their future distributed systems. All right, so is this all a fantasy? No, it's a reality. That's why you're all here today, right? You're all here because we're talking about Apache Mesos. And the way we really think of Apache Mesos is it's this data center kernel. It's this path along the way to an operating system for the data center. We really think of it as more like a kernel than the full operating system. Or another way to think about it is it's a distributed systems kernel. It's something that it can allow you to more easily build and then run your distributed systems across a bunch of machines, across a bunch of resources, all inside your data center. And there's been a bunch of these distributed systems that have already been built. So as far back as 2009, when the project started, the first one of these distributed systems that we built was Spark. And a fun story of Spark was the very first version of Spark was about 1,200 lines of code. And it had almost all of the features that Spark has today. The core primitives, RDDs, these things. And the reason why it was only about 1,200 lines of code is because it was able to leverage the Mesos platform to actually to make it much easier to actually build the system. Apache Aurora was started in about 2010. It was open source much later, but I mentioned it. There's going to be a talk from Bill Farner on it later today. And then more recently, last year, there were two more that were built. Kronos, which is a distributed cron-like framework, and Marathon. And Kronos is the one that I like to call out in particular because Kronos was a highly available, fault-tolerant, distributed cron system, and it actually never opened a network socket. It was able to actually leverage the primitives of Mesos itself to build this kind of distributed system, which I think is really, really fun. There's been other frameworks that haven't been started on Mesos, that haven't been written to begin with on Mesos, but they've actually been ported to Mesos. So obviously Hadoop, lots of the folks that probably raised their hands today are running Hadoop on Mesos. Storm, which is the lightning bolt. I don't know that there's a logo for Storm, but this is on their website, so that's the logo I'm using. Jenkins, which a handful of folks use as well. Things like Elasticsearch and Cassandra. There's been a whole lot more. I'm just calling out a few of them. And there's been a bunch of folks that have started using all these frameworks. As early as 2010, as Chris was mentioning, Twitter really adopted Mesos and has been pushing it more and more since then. But in the past couple of years, there's been a host of companies that have adopted it to use it for all sorts of things. There's more companies as well. It's highly likely that you're one of those companies and your name is not up there, and I apologize, there's only so much space. I just grabbed the companies that I've had a tighter interaction with, but we thank all of you guys for using Mesos as well. So we've had a lot of releases. The project has had a lot of releases, and this is where I'm going to kind of kick into a bit more of the, all right, community aspect of the project, what's been happening in the past, what's going to happen in the future. Right? And so the first thing I really want to call out is we're trying to do about a release a month. I hope those folks that are using that find that to be a great thing. At Twitter, we actually run Mesos off of master, and we do a release every 2 weeks. So most of the releases that are actually get put out there have been running in a production cluster on many, many machines for some period of time. I'm especially excited to announce that we're releasing today, which is fantastic, yep. That release will be done by the end of the day, and you'll be able to download that today, and I'll talk through the rest of the talk about some of the things that are in that release that are pretty fun. Okay, so yeah. Cool. All right, in the past 6 months, we've had about 38 contributors to the project. The project has 23 committers that are also PMC members. The way that we actually structured Mesos project is if you're a committer, you're also a PMC member, which means you can not just commit code to the project, but you have a full vote on the direction of the project. So just for fun, I kind of listed a couple of the other big Apache projects to give you some perspective for where we currently are as an open source community and where we really want to go. So projects like Storm and Kafka have 13 and 15 committers, Zookeeper 16, Cassandra 25, Thrift Spark. Ultimately, we want to get up to having 82 committers just like Hadoop, but we're really happy with where we're at today, and more important, the trajectory that we're going. We have about a new committer every month. So for folks that are interested, please contribute to the project, and we're looking forward to making all of you guys committers. Okay, so what have these guys been up to? What have these contributors to the project been up to? Lots of really, really awesome stuff. So I'm going to highlight some of them. This is not everything, but I'm going to highlight some of the fun stuff, and then we'll go from there. All right, so some of the biggest work that's been happening has been around containerization and isolation. So Mesos has used containerization and isolation technologies for a long time. Since 2010, we first used LXC directly in order to get Linux containers. In 2012, we moved directly to using control groups. In 2013, we started using some of the namespace features specifically for doing network namespace work. And in 2014, we incorporated Docker as well. So in fact, in the 0.20 release, I'm really excited to announce that we're going to have first-class Docker support, which means when you download Mesos and you build it on a Linux box, unfortunately not on a Mac just yet. I know you can run Docker on Mac, but we don't have support for that. When you download and build it on a Linux box, you can use your Docker images. You can describe the way you want to run the Docker images using first-class Docker constructs like volumes and entry points, so forth and so on. And these slides will be available afterwards, and I'm going to link to a lot of the documentation for this stuff where you can go learn more about that. So that's really exciting. So kind of what does that look like in pictures? Well, the Mesos slave, which is responsible for running all the tasks on each of the nodes in your data center, has historically had what we've called the Mesos containerizer. And the Mesos containerizer is responsible for doing isolation of your computations that you're running, whether it be CPU isolation, memory isolation, or disk isolation. And we introduced the ability to actually run multiple containerizers at the same time. So you can continue to run the existing Mesos containerizer, but you can also run what we call a Docker containerizer. And this lets you actually then run Docker images. It's pretty nice, right? All right. This lets you run Docker images directly alongside with all the other stuff that you happen to be running. So it's important to note that you'll be able to upgrade your Mesos cluster and just get this functionality without ruining all the stuff that you're running before. OK, so another thing we've been working on in the past really 12 months that I wanted to mention is monitoring. So the ability to actually get statistics for the containers that you're running. So why is this important? Well, when you want to start treating your data center like one big computer, you want to be able to capture the usage and the statistics of your containers that you're actually running in your data center. So we've actually supported this for a long time, since I think maybe 0.16 or so. More recently, in 0.20, we added support for networks, so we're actually also capturing the amount of network that your containers are using as well. So this is pretty great. You can just hit the Meso slave endpoints to capture this information. You can put it in whatever existing time series database you already have, whatever monitoring solution you have, send it to New Relic, whatever it is that you need to do. But we actually collect that information for all of your containers, which is pretty fun. OK. And again, you can learn more about this by specifically the network monitoring by going to check out this documentation in our Git repo. All right, next is authentication authorization. So why do we care about authentication authorization? Because we want Mesos to be used beyond just walls like inside Twitter. We want it to be used in real-world enterprise-like scenarios. So we've introduced these concepts. So for authentication, we introduced the basic idea of credentials, which are based on principles and secrets. We built the entire protocol around SASL, which is great because SASL is designed to make it really easy for us to swap in and out other mechanisms. In particular, Kerberos is a mechanism which has actually already been swapped in by some companies that have been using Mesos. And at some point, we hope to also capture that back into the open source project as well. All right, and for authorization, we introduced access control lists. An example of one is what principles can run what tasks in your data center. This is based on this action can be performed by these subjects on these objects. We have a nice little JSON representation of that. But just like authentication, this is completely pluggable. And I wouldn't be surprised if maybe somewhere out there, one of you folks implements the LDAP module integration, and we make you a committer, which would be great. All right, again, for authorization, you can go read more there. All right, so fault tolerance and high availability. One of the things that I think everyone in the community is most proud of about Mesos is that the entire system is fault tolerant and highly available. You can kill any of the components at any point in time, and the system can actually recover. There's a bunch of different features that we've built over the years to actually make that be a reality. The one that I really want to mention is what we call Mesos slave recovery, because I just think that this feature is really, really cool. It doesn't get talked about a whole lot, but I think it's so cool. So again, we kind of have a zoom in of a Mesos slave, and you see this Mesos slave process, which is managing two different containers where you're running some computations in those containers. With the Mesos slave recovery feature, what we're able to do is actually let the Mesos slave process itself die. And when it dies, the containers continue to run. And when the Mesos slave comes back up, it can re-find the containers, and everything just keeps running as normal. So why is this really awesome? It's awesome because it means that you can upgrade a Mesos cluster without having to kill any of the tasks that you actually have running in that cluster. So that's really, really cool, right? Because oftentimes you might be running things like, say, a 30-gigabyte memcache, and the impact to your site of trying to, say, kill that 30-gigabyte memcache and move it to some other place could be a big deal. Before this was built, the time to do an upgrade of Mesos in a Twitter cluster was in the weeks. After this is built, it was in the days. And again, as I mentioned before, Twitter does bi-weekly deploys. So features like this are really, really important. OK, so this has actually been a feature that's existed for a really long time. You probably have it turned on by default if you're running Mesos today. It's been turned on by default from 0.15.0. You can turn it off if you want to. More importantly, you can read more about it by checking out this link. OK. So that was just a quick overview of a couple of the really cool features that have been built in the past 9 to 12 months. Now I want to talk about what's being built going forward in the future. So this is all really, really exciting stuff, too. I think that Mesos is kind of at a really fun renaissance period in terms of a lot of these new features that we're building. So first, we're building a lot more features for running stateful applications. So a lot of the apps that folks run today are stateless apps. Or analytics, which can deal with failures really, really easily. We're actually introducing new primitives to make it much more easier to run stateful applications. In particular, things like HDFS, things like Cassandra. You can run Cassandra on something like Mesos today, but the failure modes are not as nice as if we were to introduce some new primitives. So I'm not going to talk into detail about what these primitives are. You can check out this Mesos Jira ticket to learn more about it. What I do want to talk about is why this is awesome. The reason why I think this is so great is because for a lot of folks, especially the folks that are using Mesos, they're using Mesos to run all their stateless stuff in their analytics, but then alongside they're running their storage someplace else. And they still have two clusters that they're managing for actually running their Mesos clusters. And we're going to make it so that it's just a single cluster, which is great because you have a single interface to actually manage all those things. And you can do all the other nice things in Mesos, like increase resource utilization, provide better resource sharing, so forth and so on. So related to that, we're also going to be introducing a lot of primitives around maintenance. So maintenance, that doesn't sound that sexy, but maintenance, or what I like to call planned failures, they are a reality. Even in the cloud, they're a reality. I actually think it's fantastic that Google, and perhaps AWS does this as well, but I'm not sure. Google actually tells you before you go to launch a virtual machine in a zone when they plan on doing maintenance in that zone next. So you can actually try to think about, oh, when am I going to have to possibly shut down this virtual machine? Well, so maintenance is a reality. It can happen. And we want to introduce the ability to provide more feedback to the actual Mesos frameworks that are running when it comes to maintenance, so we can do smarter things about how we reschedule tasks. So to kind of drive this point home, here's an example of a Mesos slave that's running with a task and another Mesos slave that's completely empty. When that Mesos slave is tagged for maintenance, we want to be able to drain all the tasks that are currently running on that box to another place. That could be as simple as just, killing the task and rerunning in another box. But with these maintenance primitives, we'll also be able to do things like keep the task up and running, start the task in a staging mode where, say, if it's a memcache server, it can start filling its cache. Once that's all up and down, then we can drain the task, and then ultimately we can remove that box. So this is getting us closer and closer as well for those of you that are using physical machines in your own data centers, to making it even easier for the operators and the developers to have completely no interaction at all whatsoever. Good. All right. So you can learn more about this. There's a couple tickets for this. This is the one that I wanted to call out, Mesos 1592. OK, primitives for smarter resource allocation and scheduling. So there's a bunch of stuff that we're doing around that. I just wanted to call out one, which was in the original implementation of Mesos. The way that we actually did resource allocation is what the Google Omega paper correctly called pessimistic, which meant that when we were making resource allocations, we were only making them to one of the frameworks at a time, and the other resource, and not to multiple frameworks at the same time. OK, so Omega was great because it introduced the concept of being able to do optimistic resource allocation. The good thing for us is that Mesos is a natural fit for being able to do optimistic resource allocation as well. And that's something that we're going to be integrating into Mesos in the next couple months. So this is what I like to call bringing Omega to Mesos. And you're all going to hear later this afternoon from John Wilkes. He's our other keynote, which I'm thrilled to have here. And he might talk a bit more about Omega. We'll see. OK. Finally, a couple more improvements in resource isolation. We're not done yet. We're going to keep adding more and more hooks into the Linux control groups and namespaces and other Linux kernel features for doing resource isolation. In particular, we're working really actively right now on network bandwidth isolation. And we're also going to be introducing disk block I/O isolation. The fun thing here is that we're going to make this work with the existing Docker containerizer as well. So it's likely that you're going to get things like network isolation and disk block isolation using Docker on Mesos pretty early. And we're going to try to push a lot of that work back out into the libcontainer work that the Docker folks are doing as they factor out their own containerization stuff as well. So I think that's pretty great. All right, and then the two more. For those of you that have actually built a framework using the scheduler Executor API, we're going to be revising it. It was a 2009 relic. The protocol is actually HTTP instead of Thrift or any of the other RPC-like mechanisms. But it wasn't REST. And we're going to be sort of bringing that into the 2014s. We're going to keep everything completely backwards compatible, but we're going to introduce a bunch of functionality that's going to make it even easier for folks to actually build things against the Mesos API directly on top. All right. And this one in particular I wanted to call out because it's really the last thing that we wanted to do until we'll probably do a 1.0 release of Mesos. Just to be clear, while we're not a 1.0 project, we all believe that this is very much production-ready software since it runs in production at many sites. And the main reason why we haven't made it 1.0 is because we want to do this kind of stuff first, this kind of API tweaks before we go wreak havoc on the community. OK, the last one that I really want to talk about is the Mesos CLI. So the Mesos CLI has existed in the project for a while. I see some faces out here that have actually contributed different CLI features, which is great. Why is CLI? Well, working with your data center computer should be just as easy from the command line as anything else. So I actually want to show a real quick demo of the new CLI because I think it's pretty awesome. So it more or less looks exactly like the old CLI, which to me is a great upgrade. Let's see if I can. OK. All right, so I'm just running a little local cluster on my box. I'm typing Mesos PS. And I don't know why it's so slow, because it's Python. OK. I don't know why that just happened. Let's try to swap back to. OK. All right, so this is great. If you've used the Mesos CLI in the past and you've typed Mesos PS, you've seen output like this. These are just some tasks that I actually have running. All right, good thing my talk's almost over. All right, because I don't have power. So here's what's so great about the new Mesos CLI. Tail has always existed. Cat has always existed. These types of things have always existed. Except now, I start typing echo, because as you see, I've got two tasks running, one called echo world and one called echo hello. And I hit tab twice, and it starts to do tab completion for me, which is pretty fun. And I hit tab a second time, and it tells me actually the tasks I have running. So this is great, right? The point is this is just one big computer that you have out there running. You should be able to interact with it just like you interact with the computer that's sitting on your laptop. So that's I think, pretty cool. We can just start tailing this and start seeing the output. In fact, we might have multiple files in our sandbox. We get tab completion for the files in the sandbox even. It's pretty awesome. A huge shout out to Thomas at Mesosphere, who took the old CLI and redid it in this amazing beautifulness. OK, so I'm going to now wrap up. And I want to give a fun parting thought, which is, if today's computers are data centers, does that mean multiple data centers are tomorrow's clusters? I think one of the things that we're also really excited about in Mesos is starting to think about the MultiDC effort when it comes to this kind of stuff and what it takes to do that kind of stuff. All right, so everybody, please enjoy MesosCon. I'm really excited about the rest of the day. You can run Mesos on Google. Mesosphere put this out on Monday, which is fantastic. It's the fastest way to get a Mesos cluster up in someone's cloud. So thanks so much. Have a great MesosCon.